Hey guys, Colin here, hope you're well. Today we're going to take a look at a malicious JavaScript sample, which is really interesting because it has multiple layers of packing that we need to work our way through in order to unravel what the JavaScript is designed to do. It's also got a lot of junk code within it, and we need to navigate our way through that junk code as well. I'm going to show you some tools and techniques that you can use in your own environment, including a technique that I call the matching bracket method, where you can actually navigate your way through this code super quickly without having to reverse engineer every single line of it. So the sample we're going to take a look at is here on VirusTotal. You can see it's got a detection ratio of 0 out of 58, but trust me, this sample is malicious, despite the fact of what VirusTotal will tell you, so treat it with caution. The sample is designed to reach out to the internet, download an executable, and then run that executable on your virtual machine, and that will be the NetWire rat malware. And NetWire rat is definitely something you don't want in your environment, so please treat this JavaScript as malicious. So let's have a look. We'll get straight into the code. I've got Sublime Text here. You're going to need a package installed in Sublime Text to play along at home. What you can do is go to Tools, go to Command Palette, go and type in Install Package, press Enter, and then what you can do is search for the Prettify plugin. And now it doesn't show up in my list here because I've already got it installed, but you will see Prettify listed. You can just select it and it will install that package for you, and that will give you the ability to prettify HTML, CSS, and more importantly JavaScript code really easily. So I'm going to highlight this text, I'm going to create a new file, I'm going to paste it in, I'm just going to call this copy.js for now, and I'm going to press Command-Shift-H, which is a shortcut for the Prettify plugin, and that will prettify the JavaScript for me. If you're on Windows, it's Control-Shift-H, or on Mac, it's Command-Shift-H. You can see it's prettified for me, give me some syntax highlighting. Well, that's great. I'm just going to put this on a new line to kind of like break up my functions a little bit to make it a little bit more readable. Press Command-Shift-H again, and it will again kind of take that syntax and just make it again a little bit more readable for us. So we can see here the first line we have a call to eval, and then within the body of the eval brackets we've got this function, 6 parameters passed this function, and that spells out the word packer. This is a common packer which is used on the internet to pack JavaScript, and then we have some variables being defined and also manipulated, and we have all some parameters which are passed to the packer function as well, which are declared down here or defined down here. So what we're actually interested in is the return value of this packer function. So rather than returning the variable p, which is the first parameter that's passed to the function, what we're going to simply do is just do console.log, and then we're going to put p in the brackets. Hit save. Let's go to our terminal window, and then we're going to run node copy. And then we can see we get a load more code that's output. I can't really read it in the terminal window, so I'm going to redirect this to 1.js. And let's open 1.js, and we can see what we're left with. Press Command-Shift-H or Control-Shift-H if you're on Windows again, and we'll just get it prettified. I'm going to tidy it up a little bit as well. Press Command-Shift-H again, and we can see here we've got a very similar function. We've got a call to eval, we've got a function which takes 6 parameters, some string manipulation, and then it's returning the first parameter that's passed to the function, which is in this case the variable b. A little bit different, we have a single line of code here on the top which is defining an array, and that array is also being used, and the reason why that's being defined is because entries in that array as well as some other integer values are being passed as parameters into that packer function. So this is the same function that we saw in copy.js, it's just got different variable names, and so again we're going to do exactly the same thing. Instead of returning b, we'll do console.log b, put the b in the brackets, hit save, go to our terminal window, and run 1.js. We can see we get more code. So let me output that to 2.js. Go back to the terminal window, go back to the Sublime, let's open 2.js, Command-Shift-H, and we can see we're actually got a lot more JavaScript, which looks very noisy indeed. I'm going to tidy up the function calls again just a little bit, so I just like a new line after my opening brackets, press Command-Shift-H, and I'll just tidy it up, give me a few more line breaks just to again make things a little bit more readable. If I go right to the bottom, we can see I've got like 4,300 lines of JavaScript. That would be very tedious for us to reverse engineer, so we'll just step through it, and I'll show you this matching bracket technique that I like to use in order to skip through code really quickly. So you can see the first 2 lines, right? JavaScript will execute top down, left to right. So the first variable is an array which has been defined, so that's definitely going to execute. The second line is another array, it doesn't have a name, but it's going to be defined as well, and that references some of the values of the first array. And this might be noise, right? So let me just copy it out, and we'll just see what those actually equate to. Let me just put these in a different file. I'm going to call this test.js for now, and I'm going to console.log the value of the second array. I'll hit save, go to my terminal window, do node test, and we can see here, right, we've got all of this like JSON like syntax with kind of profile information, with like placeholder text and placeholder URLs and stuff like that. And this is all noise, right? This is part of the noise that the bad guys have injected into this particular code. So anyway, let's ignore it. Those two lines are going to get executed, and on line 4 here we have a function which has been defined and then a load of code within the function. Well, I don't really want to reverse engineer all this horrible looking code. What I want to find is what references this function. So let me copy it, press Ctrl and F and paste it in here, and press enter, and we can see that the only reference to this function is actually the function that's being defined. So it's not actually being called anywhere in the code. So that's great. We know it's noise, it's not being referenced anywhere. Let's skip past it. Well, we've got the open bracket here after the function declaration. What we want to do is find the closing bracket. So this is the matching bracket technique. If you wanted to, you could scroll through and you can kind of guess your way through it, or you could kind of work your way and keep track of all the brackets. Easiest way to do it, Sublime Text gives you a super handy shortcut, which is Control and M. Even if you're on a Mac, this is Control and M. Same for Windows, Control and M. It's not Command and M, it's Control and M. You press Control and M, you'll find the matching bracket. In this case, the matching bracket is on line 543. I definitely wouldn't have scrolled through 500 odd lines of code and realized that my matching bracket was down there. Press Control and M, you'll go back to the top. So again, we'll go down to the bottom, line 543. Everything, those 500 odd lines of code, I can now ignore. Happy days. So the next line is a variable. It's an array which is being defined. That's great, we don't need to reverse engineer it. It's probably going to be referenced somewhere else in the code. Let's see what's next. We have another function call. Let me Control C, Control F it, and we can find it doesn't get referenced anywhere. The only reference is the function declaration. So let me go to the bracket, press Control and M, and we can see that the matching bracket is on line 1120. So again, we're just cutting up, we're slicing up this JavaScript, and we're now on line 1100, and we've been looking at it for about 20 seconds. We can see the next instruction is a very familiar call here. We have eval, and in the brackets of the eval we have a function, and that takes 6 parameters. Well, we saw that in 1.js and we saw that in copy.js. Chances are this is our Packer routine. It looks like, though, we've got some more of these familiar kind of junk function calls within the body of the Packer function. So let's go to our open bracket, press Control and M, and we get to the closing bracket of the Packer function. And you can see the parameters that are being passed to it are part of the array which is previously defined, and the return value is the variable dm, which is the first parameter that's passed to the actual Packer function as well. So rather than returning dm, again, we're going to do exactly the same as what we did before. We're going to console.log dm, press save, terminal window, run node 2.js, and we can see that we get an error thrown. And that's fine, right? Let's kind of think about this out loud a little bit. We can see here we've got 2.js line 3207. It's telling me that WScript is not defined. Well, that's great actually, because I'm not on Windows. I'm using a Mac, and WScript is not recognized on on my Mac. It's recognized in Windows. So WScript.sleep, which is if you go back to the error message, WScript.sleep in brackets 32 is the line of text it's got a problem with. Well, that's fine. It's just sleeping. That's probably some kind of like sandbox evasion or whatever. We can see here if I search for WScript within the code, I've got an entry here on line 647. I can just comment that out. Let me go to the next one. Let me see if there's any others that exist. And we can see here, this is the one that it threw the error on, WScript.sleep32. Let me comment that one out as well. Let me see if there's any others. Let me just do WScript. Just those two. Okay, that's cool. So let me go back, let me save it, and let me go back to our terminal window, run 2.js again, and we can see this time that it executes fine, no problems whatsoever. And we can say, right, okay, let's redirect that to 3.js and see what we're left with. Let's open 3.js in our text editor. Command-Shift-H, and we can see we've got very similar stuff to what we saw in 2.js. We have this array being defined, and it looks like we've got a load of junk code as well. So let me tidy it up a little bit. So let's search for this particular function. Control-V, doesn't happen. So this is a junk function call. Let's go to the open bracket. Let's press Control and M, and we'll get to the matching bracket, line 150. And look again, we've got a very similar thing to what we saw in 2.js and 1.js and copy.js, right? We've got eval with a function, and it takes 6 parameters. We've got a load of junk that's in the middle of it. So let's go to the open bracket. We'll press Control and M to get to the matching bracket, and we can see here that the matching bracket is right down here on line 1689, and we can see that the actual the return value of the Packer function is the variable _4. So instead of returning it, we'll do exactly what we did before. We'll put _4 within the brackets, and then we'll run 3.js. So let's do node 3.js. Cool, we're getting more JavaScript, so hopefully we're getting somewhere now. So we're peeling back the layers of this particular sample, output it to 4.js. Let's have a look at 4.js, and hopefully we'll be getting somewhere. Okay, right, we've got something which looks a little bit different. So, okay, it still looks noisy, but it looks a little bit different. Let me tidy it up, Command-Shift-H again. Okay, so it just gives us some extra line breaks, and we can see, right, okay, we've got this function which is being defined right at the top. Control and V, this is the only declaration, the only entry of this function is this declaration itself. Let's go to the open bracket, press Control and M, we'll get to the matching bracket. I'm 100 lines in. But the next line, look at this next line, right? We have a variable which is defining a new ActiveX object, which is a wscript.shell. Well, it's definitely of interest to us. Let's copy that. I'm going to paste that into a new file for now. Next line is a function that's being defined. Control and F it. Does it exist? No, it doesn't. So let's skip past it. We'll do exactly what we're saying, the same as what we did before. Control and M on the open bracket. And we'll get to the closing bracket, the matching bracket. So we're on line 276 already. We have another ActiveX object, scripting.filesystem object. Great stuff. It looks like we've got the bad guy's code, which is coming together, right? So it's in between all of this code, we've got all of this noise, and we just need to get rid of the noise, right? Just skip past it. Another function call. Does it exist? No, it doesn't. Okay, cool. Control and M, we'll get past it, get to the matching bracket. The next line, we can see that we've got this. We have a file path being defined here, so we've got a variable which is going to be the scripting file system object. We can see get special folder 2, which is the temp directory, and here's the file name that's going to be actually written to. Okay, let's keep going. We've got another function call. Does it get defined? Control and F. No, it doesn't. Let's go to the matching bracket, press Control and M. Just get past it. I'm on line 540 already. Okay, cool. The ADOBD stream has been defined. Fantastic. Oops. There we go. Right, save that. Great. We've got another function. Is it referenced anywhere? No, it's not. Let's go to the open bracket. Press Control and M. We'll skip past it. We can see here, right? Open. The method to open. Type equals 1. We've got another function call. Okay, looks like junk. Control and M. Let's get past it. Cool. Position 0. That's going to be the position where the file is where you start to write the file. We can see another function call, which is again looks like junk. Control and M. Get past it. We can see the ActiveX object. We can see the Win HTTP request now being built. Fantastic. We've got another function call. God, there's so much noise in this. It's unbelievable. Control and M, get past it. And we can see, right, here's the open to the GET request. Fantastic. Now we've got our network indicator. So we've got an IP address and a full path. We can see it to GET request. Fantastic. Right, we've got another method here. Control and M, just get past it. It looks like total noise. We can see there's the send method. Oops. There's the send method. We can see here's another function call. It looks like junk. Control and M to get past it. You can see where we're going here. And we've got some logic this time, right? So we can see if status equals 200. So it's going to perform that. It's performing that send that get request with the send method, and then it's going to look at some logic, right? So if the status is 200, well, what's it going to do next? We can see that we've got some noise in the body of this if statement. Control and M to get past the noise. And we can see here that we've got write response body. So if it's a status of 200, it's going to get the response body and it's going to write it somewhere, and that somewhere is going to be the file path that was previously defined. Another function, Control and M, just to get past it. And we can see a little bit more logic here. So if the file exists, then delete the file. So if it already exists, then it's going to delete the file, overwrite it, or just start a new one. Another function looks like noise. Control and M. Let's get past it again. Save to file. So it's gonna, if it exists, it's gonna save it, and if it doesn't exist, it's gonna hopefully write it anyway. Another function. You can see where we're going. Control and M. Just get past it, and we can see right the connection is going to be closed here because obviously the job is done. The file is written. We've got another function. Control and M. Just to skip past it. Okay. If it doesn't exist, then delete the file. Okay. Cool. Right, another function looks like noise, Control and M. We can see here, this is actually where it's going to execute. So we're going to, or this is the command to execute it. So we can see cmd.exe, the command string being built. We've got another function call, Control and M, get past it. And we can see here, here's the method, here's the run method to actually execute the binary. Another function call, looks like junk, Control and M. Let's get past it. And what we're left with is our closing bracket to close down that for loop. Close down the if block that we're in. Okay, cool. Let's just double check ourselves. We're on line 2,500 here. We've got another function, Control and F. Does it exist? No, it doesn't. Control and M, just get to the matching bracket, and the matching bracket is actually the last line of our code. So here, is the bad guy's code, and we've extracted that from like 5,000 lines of code or whatever it was to begin with, and we can now see the logic. So we've got wscript.shell, we can see the file path, we can see the stream, we can see the win HTTP request, we've got the key network indicator, which if you reach out to is actually going to be an executable, and we can see if the response body, if the status is 200, the response body is going to be written to the file name that was previously defined, and then we've got the run method, which is actually going to execute the file on your machine. So hopefully you find that useful. Super easy method that you can use in your environment to skip past noisy code using Control and M to find that matching bracket, and hopefully that will help you wade your way through these kinds of noisy samples that you see in the wild. Okay, thanks guys, all the best.